Hi everyone, welcome back to my channel. So today we will solve problem combination sum. So this is a LeetCode standard problem, and it is a famous problem for recursion. So we will figure out how to solve it. So the problem statement is that given an array of distinct integers candidates and a target integer target. So we have an array candidates. It is an array, okay, and we have a number target, okay. So we need to achieve target, and what we have to return, we have to return all the unique combinations of candidates where the chosen number sum to target, okay. So in the candidates only we have to choose a list of numbers, okay, which will eventually sum to target. So you may return the combination, so order doesn't matter here. The same number may be chosen from candidates an unlimited number of time. So okay. So this is the condition we have added. Like if there are, let's say, I will take example only 2, 3, 6 and 7, okay. And now we have to find of target of t is 7, okay. So what we one combination you can see 7 is the answer, okay, but you can choose any number unlimited of number of time. So let's say 2, 2, 3, okay. So you've chosen 2 times, you can choose 2 3 times, you can choose 3 2 times, but eventually you have to find the target, not more than that, not less than that, okay. So eventually, so you can, as you can see, there are 2 combinations. So yeah, this is our example. We cannot found any combination like greater than 2 to found the target 7, okay. So yeah, we will solve this problem. So let's deep down more onto this example itself, okay. We'll come here. 2 3 6 7, okay. Let's say this is our array, okay, and we have to choose a combination where the sum leads to the target 7. So how human would solve this problem, okay. Let's say I have to, let someone ask me and I don't know about recursion and everything, okay. So how I would solve this problem, what I will do, I will first choose the first number. You can, of course, it's my brain, I can choose anyone, but if I have to generalize my approach, what I will do, I will choose the first number, okay. 2 I have chosen. Now I will see what's my target. My target is 5, okay. As I know I can choose this number again, okay, then I will again choose 2. What's the target now? 3, okay. Then I can choose, yeah, 3 is greater than 2, still I can use 2 again, okay. So I will choose 1 2 again. So my target will be 1 now, but now I would see my target is less than the current number, the smallest number, okay. Or yeah, if I would solve, then I would solve, I will sort these number also. So I need to choose from the smallest first, then I will, okay. So how I would solve this problem, I was thinking that, okay. So but now you can see t equal to 1 and my target is 2. So my target is 1 and my current number is 2, so of course I cannot choose this number now, okay. So I will go back to this. Now what I will do, I have my target 3 and I have chosen the number 2, okay. So my target 2, I will see if do I have number any, I will go to the next number. If I will see can I use this number to complete my target, yeah, I can see I can use 3 to complete my target, okay. So yeah, from here only I will go to, I will choose 3. Now my target is 0, I have chosen 3, okay. So so yeah, now you can see I have I have chosen 3, my target is 0, and so as my target becomes 0, I have achieved my number. So yeah, one way of solving this problem would be I will choose this number, then I will again choose number. If my target somewhere leads down to less than the current number, then I will go back and I will again follow same approach. I will like search for the next number whether it's equal to target or less than target, then so I can use it. I will try to use the numbers, and I will solve this problem. Okay, so here my answer would be, like you can see, one of the my answer would be 2, 2 and 3. Okay, this is the number we have chosen. Now as you can see, at every point, okay, at every step, the question is still the same. What we have to do, we have the same set of array again. Okay, we have the same set of array again. What changes? The changes are in our target only. Earlier I have to find out the target of 7. Okay, now I have to find out for target of 5. Now in the next step I have to check for the target 3. In the next step I have to check for the target 1. Okay, so now my question at every point remains same. So from there only we can like think of intuition. I would like that if a problem calls itself, okay, if and by using that we solve any problem, so in that place we can use recursion. Okay, so how would be a recursive, how would be a statement of a like recursion call? Okay, so each recursive call, okay, means that I am currently building a combination and I can only choose number, okay, from the starting of the index. We will set some rules for that. Okay, so let's say I'm choosing the number from the starting of the array only. Okay, so what would be our recursive call? It would be that I'm currently building a combination. This is our combination, and I can only choose number starting from the start index. This is our start index, let's say, for the array, and I still need remaining sum. What is the remaining sum? The remaining sum is our new target. Okay, so yeah, and I still need like this sum to reach the target. Okay, okay, so this would be our recursive call kind of a statement. We can use that. Okay, so from here, yeah, we have got that idea that we will use recursion to solve this problem. Okay, so whenever like recursion comes into the picture, so what also comes with it? The base case. Before base set, can you think of like how a function would look when we want to call the recursion? Okay, so we have an array. Here it is written candidates. I can say it nums. This is an array. Okay, let's say this is our recursive function. Okay, we will need an index which would be a starting index. Okay, from where we will choose a number. Okay, then what we have target. Okay, we will have some temporary vector which will store our current answer, the combination which it will store our combination. Okay, okay. So yeah, this is our recursive function that we will use to solve the problem. Okay, now this looks good. Yeah, so coming to the base case again. Okay, what could be our base case? Okay, so one of the like standard base case which we always use, if I is greater than nums of size. Okay, so yeah, let's say I'm starting from the index 0. I have choose first number, I have chosen second number. Let's say my target is 100 here only. Okay, let's say my target is 100 here. Okay, I am starting to choose the number. I am choosing 2, then 3, it would be 5, then 6, it would be 11, then 18. It okay, the total number is 18 and my target is 100. Still I haven't reached the target. Okay, so let's say I cross the index I plus 1. Okay, so from choosing all number like only once, I haven't reached the target and I have made my index to I plus 1. The like I is my greater than nums of size, I is greater than 4. Okay, so that time that is an invalid combination. Okay, and I will not include in my answer. Okay, so that like that is a basically we don't have to return, we have to like return here. We don't need that sequence, that is an invalid combination. Okay, so we will not do. So one of the standard base case, it would be always there in recursion, right? If you are traversing through array, if you are traversing through an index, then it would always be there. Okay, now just think of second base case. So as you can see this point, okay, what happened at this point? Our target was 1 and our number was, okay, our current number at current index was 2. Our target was less than the 2. Okay, uh, this would be actually logical condition, this won't be a base case. Okay, you can think, you just look at this. Okay, our target was 0. When our target was 0, okay, we have included to our answer. Okay, so it means we don't need any more number or anything else to check. If our target is 0, yeah, that combination is valid and we can include our answer. Okay, so yeah, one thing is that if our, I will say t target, you can refer, we have an answer, we will push back that temp and we will return. Yeah, okay, so yeah, one of the cases is like base cases is. And what would be one more base case if target equals 0? Let's say, okay, let's say what, let's see the next case of this. Okay, the next call of this. Okay, how I have decided that, yeah, that this sequence won't work. Okay, what I have done, I have chosen to, okay, now my target is 1 minus 1. I have chosen to, my target is minus 1 2 and our current index is 2. Okay, so when our target is negative, of course we know that we cannot make negative integers from the list of the positive integers. Okay, so I will return from here also. Okay, if target is less than 0, we cannot do, we can return from here. Okay, so yeah, these all are the base cases. Okay, like you can combine them, you can form a single base case, you can, like, it's on you, it's on up to you. Okay, so now we will do, what we will do, we will solve this problem. Okay, what we have, what we are given, we have vector of int combination sum. Okay, okay, it's something like that. I will vector of int combination sum. I have, this is a function actually. Okay, what we have given, we have given a vi, a vector of int candidates cnd. Okay, we have given a target, do we have something more also, candidates and target. Yeah, so yeah, now we have to write the solution here. Okay, so yeah, we can include all the base, just you can see this. Okay, this was our base case. Okay, these three. Okay, we will use this. Okay, okay, so this is our main function. What things we will need in the starting, we will need an vector of int, which is like our container to store our answer. Okay, okay, now what we will need, okay, we need an temporary vector, okay, which will hold our combination, okay, at an index. Okay, now what we will do, we will, let's say our recursive function name is help, we will call this help function, okay, to help ourselves. Now we will pass candidates here. Okay, we will pass target, what is our starting index, it is 0. Okay, what is our current answer, which is temp. Okay, now we will write the help function. Okay, vector of int, let's say I will call this candidates as nums, it is target, I will call it as t, index as I, okay, vector int temp. Okay, we can pass this as reference also, we can pass this as copy also. Some statements will change if we pass as a reference. Okay, I will like told you, I will tell you also what will change. Okay, so let's say our function is starting from here. So should I write base case again here? Okay, I will write. Okay, I will write in one go only. Okay, if I current index is greater than nums of size, okay, or t is less than 0, we need to return. If t equal to 0, we have to push our answer into temp. Sorry, we have to push temp into answer and we need to return. Okay, okay, so this is our base case. Now we will think of the function that we need to call here. Okay, what, so I have to call that our recursive function is, our recursive call is this only. Okay, our recursive function was this. Okay, now we will use this recursive call, we will call it again to solve our problem, as we don't need to return something here. Okay, so we will directly what, okay. One more thing I want to tell, how can we use pick non pick concept here. Okay, so by this time you would have figured it out that yeah, it's up like we are picking some elements, we are not picking some elements, but still I will explain it. Okay, okay, so we have this number. Okay, 2 3 6 7, target is 7. Okay, so at any point at any index, what option do we have? Okay, either we will choose this number. Okay, let's say I have chosen this number. Okay, then still my array would be same. Okay, I choose this number, my target is 5 now. Okay, but I can use this number again, so my starting position would be again I is equal to 0. Okay, if I haven't choose this number, my array would still be same, because I can choose any numbers of friends. So my still but I haven't choose this number, so I will move my I to the next step, which I equal to 1. I will do I plus plus, so I will move to 1, like on this position. But my target won't change because I haven't choose this number. I have, like, it's my choice to choose a number or not. Okay, I will try all the cases. This is a case where I have picked that number, this is a case where I have not picked the number. Okay, now I will go on further. It will, as you have seen that this is the same case, I have picked and I have reached my answer. Okay, so again you will pick, or either you will not pick. Now let's say you haven't picked the answer. Okay, so you are excluding this 2 here. Okay, like it's in the array but you are not using. So our question still got the same, you need to find out the target, but the array is smaller now. Okay, so the question, the problem itself doesn't change. Okay, so this is a property of recursion, that the question doesn't change. Yeah, so we can come back here. So we have two cases, where we pick, where we not pick. Okay, so let's say first we have decided to not pick. Okay, so this is our help, we will call, we have nums. Okay, we haven't picked. Okay, so our target will change or not? Yeah, it will not change. Our index will move to 1. Our temp will change? Yeah, it will not change. Okay, Now here one, now let's say if we decided to pick that element, what we have to check? Okay, like you don't need to check because you have added this space case. If like target is 0, then it would return. But still, why to call this? Okay, why to call this, why to go at that level? Okay, so what you can do, okay, you can check first that if you're picking this element, it should not be greater than target. Like if you're choosing 2 and it's less than target, then yeah, it's okay. Let's say if here it is 8, okay, then why you would change 8 to make a target of 7? Okay, like you won't choose 8 to to form 7 na. So that is a basic common sense. Okay, so of course we will add a condition here. If, okay, if our we are at an index I, okay, nums of I less than target, okay, less than or equal to target, then only we can pick that element. Okay, so at 2 is less than 7, so yeah, we can pick. What we can do, we will, okay, before that we will push our nums, okay. Now we will call help. The number would be same. Target will decrease, yeah, target will decrease by nums of 5 because we have choose that number. Okay, I would change. Would I change? No, I won't change. You can see in this case, if you're choosing that number, you are still at that position only. Okay, because you can choose that number again now. Okay, so I won't change. We have changed temp already, so we don't need to make that amendment. Okay, now yeah, this is the answer. Okay, so I will show you what's the difference between the reference and non-reference here. If we have used reference here, okay, we are passing this temp, okay, the current answer as a reference, then we need to pop that answer. Okay, but if would haven't, like if we would have not used this reference symbol, okay, then we don't need to pop. Okay, so I will tell you what's the difference. Like most people know that if you have, like in this case we are using reference. Okay, so what will happen, the same, like it won't make another copy in its recursion call. Okay, the temp won't make another copy in its recursion call. It will always be same. Okay, in any call it will always be same. Okay, so let's say if we have temp dot push back nums of 5, okay, it goes again, it push that number, it push that number. You have got the sequence, you have reached the target, and now you want to return. Okay, when you want to return only, then also the temp would be same only. Okay, temp won't change. Okay, because you are not making in the you are not making the copy of variables in the recursion. Okay, so yeah, this is the concept of reference. Okay, so if you have declared, okay, a variable as a reference variable, okay, then if you call, if you pass, okay, that var in any function, it will store that memory. Okay, so you know memory have address, it will store that address and it will make amendment on that. It won't like make a new memory and copy all the information of that memory into another. So okay, so that's why when you use reference you need to pop that answer. If you don't want to pop that, then you can like remove the reference, you can remove this dot temp dot pop back statement. But in that case you may have chance of stack can be overflowed, because you in in that case you will use like memory. Okay, so let's say you are removing the reference variable from here. Okay, so then what happened, in every next call of recursion you will make a new memory for temp, you will copy that like you will copy that all the information from that. So this is like extra work, so we don't need to do it. We can pop that the last number we have inserted. Okay, so yeah, this is a pick. Sorry, this is not pick, and here we have picked. Yeah, this is a basically pick and not pick concept. So yeah, this is a like helper. Yeah, this is our recursive function. This is like recursive call. This is a recursive function. Yeah, so that's how. Now here what we can do, we can return answer. What happened? Okay, so yeah, this solves our problem. Okay, yeah, now we will talk about time complexity and space complexity. Actually, so this is a like recursive problem, so it would be like order of 2 to power n of course time complexity, like everyone knows in the recursion it always like that. But here we don't have, like we have a hypothetic TC and SC because the because you are like you are meddling between the recursion. Okay, so when you meddle between the recursion, you don't have a exact scenario what will happen in the in some cases. Okay, let's say if it would have been a unique combination. Okay, let's say you cannot choose that number again. Okay, then you can say yeah, we have like one pick combination and one pick two combination for every numbers. Okay, but here what can happen, okay, you can choose that number for 5 times. Okay, so in that case you don't have a like, you cannot say yeah, this would be like I can choose this, like you don't have that privilege. You don't have that privilege to say that yeah, our safety, that you can say that yeah, this would be like we have two combination always for that answer. Okay, so like we cannot say the exact time complexity, but it would be still around, like we don't have okay, so we cannot say 2 to the power n, this would be wrong. Okay, it would be close to somewhere 2 to the power t. Okay, so in every case we have 2 to the power n, like most in the most of the cases. Okay, so why, let's say if you have unique, if let's say if you can choose this number only once. Okay, then you have two, then combination for this, two combination for this, two combination for this, 2 to the power. You will try combination, it will, n is a number of, n is a like number of elements present in the nums. Okay, so your complexity will be 2 to the power n. But here, okay, your choices depends on this target. Okay, how many times you can pick this element. You can pick this 3 times because on the fourth time it will be greater than target. Okay, so yeah, so now you can see that your TC is not dependent on n this time, your TC is dependent on t this time. Okay, or let's say you have chosen on an average x times. Okay, you have chosen on an average any number. Let's say you are choosing four, this number 4 times, you are choosing this number 2 times, you are choosing this number 1 times. Okay, so let's say I'm saying that on an average you have chosen all the numbers x times. Okay, so in that case you can just remove it, this is 0. Okay, you can say yeah, 2 to the power 2 into x. And for the space complexity, you are storing the answer temp in answer dot pushback. Okay, so the it's a average length of sequence if you say m. Okay, so yeah, it would be like m into, if you are choosing this, I mean, if you're storing this temp into like an average sequence size of this temp is m. Okay, now how many times you are doing this x time. Yeah, so it would be something around m into x. Okay, so yeah, this is like hypothetical. Nobody will, you can, it's not, yeah, you cannot prove this, you cannot have a valid TCNSC for this. Okay, so yeah, so yeah, I end up this video. If you like this video, like, share and subscribe. Okay.